Our universe is vast. It stretches farther than we can imagine. For millennia, humans have looked up at the night sky. We have wondered about those twinkling lights. What are stars? Are there other worlds like ours? Today, we know our sun is just one star. It is one among billions in our Milky Way galaxy. To understand our place in the cosmos, we must look beyond our own solar system. We must journey to our stellar neighbors. These nearby stars are the first stepping stones on an immense cosmic ocean. Our curiosity fuels this grand exploration, a quest for knowledge and perhaps companionship. Our closest stellar neighbor is not a single star. It is a triple star system called Alpha Centauri. It lies just over 4 light-years away. That sounds far, but in cosmic terms, it's right next door. Imagine looking up at a sky with not one, but 2 sun-like stars. Alpha Centauri A and Alpha Centauri B are stars very much like our own sun. They orbit each other in a celestial dance. These 2 stars are a beacon for future exploration. What wonders might their planets hold? Studying this system helps us understand how stars and planets form and evolve. The 3rd star in this system is Proxima Centauri. It is actually the closest single star to Earth. Proxima Centauri is a small, dim red dwarf star. It orbits its larger companions, Alpha Centauri A and B, from a great distance. Red dwarfs are the most common type of star in our galaxy. They are much cooler and fainter than our sun. Proxima Centauri is like a tiny ember glowing in the vast darkness of space. Yet this faint star holds a discovery of profound importance. It reminds us that even the smallest stars can harbor great secrets. In orbit around Proxima Centauri, scientists have discovered a planet. This planet is named Proxima Centauri B. Excitingly, Proxima B orbits within its star's habitable zone. This is the region where temperatures could allow liquid water to exist on a planet's surface. Liquid water is a key ingredient for life as we know it. Could there be life on a planet orbiting the very next star? This tantalizing possibility drives our scientific endeavors. It fuels our collective imagination. The search for answers, and perhaps for life, continues with ever-growing anticipation and sophisticated tools. Beyond Alpha Centauri, other stars beckon. Barnard's star is another close neighbor. It is located about 6 light-years from Earth. This star is famous for its incredible speed across our sky. This movement is called proper motion. Barnard's star has the largest proper motion of any star relative to our sun. It's like watching a cosmic sprinter racing against the backdrop of more distant, seemingly fixed stars. Over a human lifetime, its position visibly shifts. This rapid journey through the galaxy makes it a fascinating object for astronomers to track and study. The speed of Barnard's star is truly remarkable. It travels at about 142 kilometers per second relative to the sun. In about 150 years, it moves a distance in our sky equal to the width of the full moon. This swift motion provides clues about its origin and its path through the Milky Way. For many decades, astronomers have searched for planets orbiting Barnard's star. Some early claims of planetary discoveries were later found to be incorrect. However, the hunt continues, as new technologies might reveal smaller worlds previously hidden from our view. Not far from Barnard's star, at about 6.5 light-years away, lies Lumen 16. This is a binary system, meaning it consists of 2 objects orbiting each other. It holds the distinction of being the 3rd closest known star system to our sun. But the components of Lumen 16 are not stars like our sun. Instead, it is a pair of brown dwarfs. Brown dwarfs are intriguing celestial bodies. They are often called failed stars because they are more massive than planets but lack the mass needed to ignite sustained nuclear fusion in their cores, the process that makes stars shine. The 2 brown dwarfs, Lumen 16A and Lumen 16B, orbit each other quite closely. Studying them provides valuable insights into the boundary between stars and giant planets. Brown dwarfs are thought to be very common throughout our galaxy. They are dim objects, glowing mostly in infrared light which is invisible to our eyes. Lumen 16 offers us a nearby natural laboratory. Here we can investigate the properties of these mysterious objects. Scientists have even detected signs of cloud patterns and weather on these brown dwarfs similar to what we see on Jupiter. Further out, at about 12 light-years from Earth, we find Tau Ceti. This star holds particular interest for us. Why? Because Tau Ceti is remarkably similar to our own sun. It is a G-type main sequence star just like Sol. This similarity makes it a prime target in the search for extraterrestrial life. Stars like our sun are thought to be good candidates for hosting planets that could support life. Tau Ceti is also a relatively stable star. This stability is considered favorable for the long-term evolution of life on any orbiting planets. Astronomers have found evidence suggesting the presence of multiple planets orbiting Tau Ceti. Some of these candidate planets might even lie within the star's habitable zone. This is the region where conditions could be right for liquid water. However, the Tau Ceti system also appears to possess a massive disk of dust and debris. This could mean that any planets in the system experience frequent and intense bombardment by asteroids or comets. Such impacts could make it difficult for complex life to arise or survive. Nevertheless, its sun-like nature keeps it high on our list of stars to watch. The Gliese 581 system, a red dwarf star about 20 light-years away, once sparked immense excitement. Several exoplanets were announced to be orbiting this star. Some of these planets, particularly Gliese 581 days and the unconfirmed Gliese 581g, were reported to be in or near the star's habitable zone. Gliese 581g was even nicknamed Zarmina by one of its potential discoverers. It was hailed in some media as the first truly Earth-like exoplanet with strong potential for harboring life. This generated considerable public interest and scientific debate. However, the story of Gliese 581 also illustrates the self-correcting nature of science. Later, more detailed studies cast doubt on the existence of some of these planets, including the much-celebrated Gliese 581g. These reanalyses suggested that the signals initially interpreted as planets might have been caused by stellar activity or noise in the data. While disappointing for some, this process is vital. Science advances through rigorous testing and re-evaluation of evidence. Even if some of its planets are not there, Gliese 581 pushed our detection techniques forward. It taught us valuable lessons about the challenges of finding small Earth-like worlds around other stars. The search for exoplanets in habitable zones remains a central theme in modern astronomy. The habitable zone, sometimes called the Goldilocks zone, is that just right region around a star. It is not too hot, not too cold. In this zone, a planet with an atmosphere could potentially maintain liquid water on its surface. We know that liquid water is crucial for life as we understand it. Thousands of exoplanets have been discovered. A growing number of these are found within their stars' habitable zones. Each new discovery sharpens our focus and brings us a tiny bit closer to answering that profound question: are we alone in the universe? We are also learning more about the dynamic nature of our galaxy. Stars are not fixed points of light, they move. Sometimes stars pass relatively close to one another in what we call stellar flybys. Our own sun has undoubtedly experienced such encounters in its long history. These close passages can have significant gravitational effects. They can disrupt planetary systems, perturbing the orbits of planets. They can scatter comets and asteroids, potentially sending them on collision courses with inner planets. Understanding these stellar interactions helps us piece together the history of our solar system and predict its long-term future. These nearby star systems, Alpha Centauri, Barnard Star, Lumen 16, Tau Ceti, and others, are incredibly important. They are our cosmic stepping stones. They represent the most accessible initial targets for future interstellar missions. Our current robotic emissaries, the Voyager probes, are now venturing into interstellar space. But reaching another star system is a challenge of a vastly greater scale. Alpha Centauri, our closest neighbor at over 4 light-years, is still an immense distance away. It would take our fastest current spacecraft tens of thousands of years to traverse that gulf. Yet humanity has always been driven by dreams of exploration. We are constantly developing new technologies and concepts. Ideas like light sails propelled by powerful lasers, advanced fusion rockets, or even more exotic propulsion systems could one day make interstellar travel a reality. These nearby stars are the logical first destinations. They offer the best opportunities to study other worlds, other suns up close. They might even hold the answer to whether life exists beyond Earth. The grand journey to the stars begins in our own stellar neighborhood. These neighbors are not just points of light, they are destinations beckoning us forward into the cosmic frontier.